Thank you for tuning in. So I wanted to make a video specifically covering alignment of the gun. If you've watched the video I did on basic operation of the instrument, I talked about how as part of starting the session you can apply gun alignments that have already been saved. So if you recall, come up here, go to the beam tab. Down here in FEI registers, you can apply gun alignments that have been saved. And I didn't really go over what exactly is entailed in doing the alignments. Okay, so I'm going to go over that as well as how to save them so that they can be recalled later. So it's been my experience with the Tecnai instruments that the gun alignments are very stable and don't usually need to be done very frequently. It's usually once every 1 or 2 months I will check them to make sure that they look okay, and usually they don't need much adjusting if at all, and then I will just update the alignment and save it, so then any user who comes in can just apply the alignment and doesn't have to worry about doing the gun alignment manually. So if we come back to the startup tab right here, okay, down here in high tension and FEI control, okay, so there's two really important parameters. Actually, I should say maybe three. One obviously is the high tension or the voltage, and then in FEI control there's what's called the gun lens and the extractor voltage. So your gun alignment is going to depend on all three of these parameters. Generally speaking, when you're operating the instrument, you're going to be running your extractor voltage at basically a preset value, irrespective of the high tension or the gun lens. Not to say that you couldn't necessarily alter that somewhat, but generally speaking, that value is kind of preset for operation at any voltage or gun lens. What you have more control over as a user are the high tension and the gun lens. So the high tension, obviously, that's the voltage that's applied to the electrons, the accelerating voltage. The gun lens, however, is something different. So that's actually a lens in the gun that provides a focusing action. And that has numerical values. I think this goes from like 1 to, I'm not sure what the upper number is. It might be like 7 or 8, I'm not sure. The basic idea though behind the gun lens is if I go lower in value, numerical value, I end up with a smaller demagnification of the gun. And concomitantly, I end up with more current in the beam reaching the sample. So it's very much analogous. The gun lens is analogous to numerical spot size. If I increase this value, I get more demagnification of the gun, which in principle means I can get a smaller beam size on the sample, but I end up with less current in the beam reaching the sample. What's interesting about this though is I have not personally, at least on this instrument, I have not personally seen a huge difference in changing the gun lens value up from this and getting a smaller probe size. I do see the change in beam current, but I haven't empirically anyway observed a substantial or noticeable, I should say, difference in the smallest possible beam size as a result of changing the gun lens. So if you're not really getting a benefit in terms of smaller probe size, like if you were doing, say, atomic res stem, by going to a higher gun lens and you're losing current, there's really very little reason to use a higher value of gun lens than is necessary. gun lens 3 is what's recommended by the manufacturer just for general operation. So that's what I leave it at. But anyway, the takeaway here is your gun alignment will depend on what is your high tension and what is your gun lens. So for general operation, we use 200 kilovolts and we use gun lens 3. We do have an alignment set up for 80 kilovolts, which I'll show you, or it's saved later if this was being used at a different voltage. So that's the first thing you need to know about doing the gun alignment. Okay, so the actual gun alignment then, I'm in startup here and I've opened up the isolation valves. So if we come to the screen here, you can see that I've got a beam. I don't have a sample in right now. That's ideal for when you're doing this. You don't have anything, blocking the beam. So first thing we need to do is change our C2 aperture. So for general operation, this is set here at number 2. I'm going to increase this to 4. Okay, and now the first thing I have to do is realign the C2 aperture. So I'm in SA mode. You can see here you want to be in SA mode when you're doing this. Okay, and if you recall the procedure, go to crossover, expand clockwise, come back up here, okay, adjust your aperture, shifting screws here to recenter the beam. And we'll do a couple iterations of this. Okay, I have a little bit bigger than that 4mm circle, expand it. That actually looks pretty good right there, so I'm not going to do another iteration. Okay, so that is the first part of this. I'm also at spot size 1. I like to do this at spot size 1 just because, generally speaking, that's what you're using when you're doing most conventional imaging. Although the gun alignment shouldn't matter, but it makes it easier to do if you're using spot size 1 because you have the most current possible reaching the specimen. Okay, so I increased my effective magnification substantially, or my indicated I should say. I'm still in SA mode, but I'm up to 175,000x. Okay, and what I want you to watch here, so I'm adjusting the C2 control, and you notice the beam isn't perfectly centered. There's a reason for that. This is going to be easier for you to see. As I go to crossover, close to it, you see inside the beam there's a bright spot. Okay, so now the first part of the gun alignment is that bright spot should be centered inside of that illuminated area. Okay, so you can see it's a little bit off to the left. If I go too close to crossover, it becomes harder to see. Okay, at least with the camera that I have here. But actually on the screen right now, I can see it more pronounced because I'm actually closer to crossover. But it's a little hard to see on the camera. But there you can still see it. You can see that bright spot, and you can see that that's not quite centered. So what this means is that the gun tilt needs to be adjusted. Okay, so how do we adjust the gun tilt? Come to the Tune tab, click on Gun Tilt. Okay, your multifunction knobs are now activated for gun tilt. With the gun tilt, I find that you want to bottom out the sensitivity with these because it is very sensitive otherwise. Okay, and now it's literally, you're adjusting to get that bright spot centered inside of that illuminated area. Okay, so actually that looks a little bit better. If I throw it off, okay, so now I'm not centered anymore. You notice the beam is kind of moving around a little bit. That's not really problematic. If you need to shift it back, use the trackball, obviously. I'm only adjusting the X multifunction, so I can go ahead and try the Y here. Alright, so you can see that's a little bit off. You may need to periodically, yeah, so that's off there. But just adjust your C2 control. Alright, so that's actually pretty good right there. Again, it's a little hard to see. I would normally do this with it centered, but if I shift it off so it's not over the circle, it's easier for you to see on the camera. Whoops. And so that's off. Okay, that looks pretty good right there. Okay, I've got that bright spot centered. So I really didn't have to make a whole lot of adjustment to this, but I did make a little bit of one. The other thing that may happen when you're doing this is you may have to adjust your condenser stigmators. So the condenser astigmatism isn't really off by a whole lot, but again, if I wanted to adjust that, I'll go ahead and hit done here. I'm in the Tune tab, select condenser, and my multi-function knobs are now activated for that. Okay, and so actually, when you have the number 4 aperture in, your beam is not going to be perfectly circular, even when you have your astigmatism of the condensers corrected. It's going to actually kind of have a little bit of a triangle appearance, which is normal. Okay, so that's actually normal right there, and now it's not. Again, the litmus test is it has to look symmetrical when you go back and forth through crossover. Does it expand with the same shape? So it's still probably a little bit off. But not too much. Okay. So that's the first part of this, is the gun tilt. And the next thing we're going to talk about is the other part of the gun alignment, which is the gun shift. Okay, I didn't mention it in the previous segment, but when I click done here in direct alignments, it did save the alignment I made to the gun tilt. Whenever you hit done or you activate another alignment, it will save the alignment that you were just working on, so you don't need to worry about that. So now the gun shift, you don't need to be at high effective magnification for this, and in fact, if you're at very high, indicated magnification, then this actually becomes more difficult to do. So I'm going to drop this down. I'm only going to go to like 13,500 for this. Again, you don't need to be, you want to be in SA mode, but it doesn't need to be that high. Okay, go to crossover, center the beam with the trackball. Okay, and now I'm going to come back to my beam tab where I set the numerical value of spot size, and I'm going to go up in numerical value. You want to go to a higher number, obviously. I'll usually go to like 6 or 7, somewhere in the middle here. So we'll go to 6. And you can see I've lost current, which is expected because I went to a higher numerical value. And now I'm going to go back to crossover. Okay, and now you'll notice my beam isn't centered anymore. Okay, so I want to center it now using the trackball. Okay, so the trackball, again, those are dedicated condenser deflector shift function. Okay, so use the trackball, center it. Now I'm going to come back to beam settings, go back to 1, go back to crossover, and now you see it's not centered again or anymore either. Okay, so now this is where the gun shift comes in. I'm going to go back to the Tune tab, activate gun shift. Okay, and now again, my multifunction knobs are activated for that. I'm going to bottom out the sensitivity, and now I'm going to use my multifunction knobs to center the beam. Okay, so this is very sensitive even at its least sensitive value, which is why I bottom it all the way out. Okay, and so now I want to do a couple more iterations of this. Okay, so I'll select done, go back to spot size 6, bring the beam back to crossover, center it with a trackball, go back to spot size 1, go back to crossover, and you can see it's basically centered. So it should get, if you're doing this properly, it should get a little bit closer each time. If you're not getting closer each time, you probably have something mixed up. You're activating gun shift when you should be using the trackball, or you're activating the trackball when you should be using gun shift. Again, what you want to do when you switch from the high numerical spot size to the lower value, and then you want to recenter it with gun shift. Okay, so I'm going to come back to the Tune tab, and again, activate gun shift, bottom it all the way out, the sensitivity, and I mean, I'll make a little bit of adjustment here, although I don't really need to make any because it's, I mean, basically it's perfect. Okay, so usually 2 or 3 iterations of this is as much as you need for the gun shift. Okay, so the last part of the alignment is we're going to go back to a high indicated mag, and we're just going to check to make sure that that bright spot is centered inside the illumination area. If it's not, we need to just make another small adjustment to the gun tilt. So I'm going to increase my indicated mag back up to 175 kx. Okay, my beam is a little off-centered, but that's fine because that makes it easier for you to see on the camera. And if I expand clockwise from crossover, I'm looking to see, is that bright spot centered inside the illuminated area? And it is. So if it wasn't, I'd go back to direct alignments, activate gun tilt, and I'd make another adjustment to the gun tilt. You may need to do that if you make large adjustment to the gun shift, but we really didn't make a big adjustment to the gun shift, so therefore it makes sense that we wouldn't have to do another adjustment to the gun tilt. So the gun alignment is done now, and so now we can talk about how to save the gun alignment. So if I come back to the beam tab here, whoops, and I go down to FEI registers. Okay, this is where I can save a gun alignment. Okay, so again, remember your gun alignment depends on your voltage, your gun lens, and if you change the extractor voltage, although again, usually we run that at just a constant value. So I've already got a couple saved in here, but I'm gonna add another one to show you how to add it. So I'm gonna type in, I'll just type in 200 kV space gun lens, or just GL3, and then if I expand this flap out here, you can see I have a few options here. Okay, so the way I set this particularly is that I just save the gun settings. What you can do if you choose, and I don't normally do this because I don't find it particularly useful, you can also save with this the mode of operation that you're in, the settings for your condenser, meaning what spot size are you at, what was the value of your C2 lens, so on and so forth, what was your indicated magnification, and that's all saved in the register. What I normally do though is I just save the gun settings here. Okay, so I just check that and I click save. Whoops, sorry. I actually just check that here. I go back and I select add. And so this adds this to the FEG registers. So now when I come back to the microscope and I'm starting the session, all I have to do to apply the gun alignment is just select the label and select set, and that applies the gun alignment. And again, my experience with the Tecnais is that the gun alignments are very stable. They usually only need to be checked once every couple of months, and unless something really traumatic happens to the microscope, the gun alignment is usually very steady and doesn't need a whole lot of adjustment. And so a user can come in, just select the appropriate register for whatever voltage he or she is working at. We have one for 80 kilovolts as well. You just select it and you hit set, and then it applies it. Okay? And so this concludes the demonstration on how to perform the gun alignment. If you have any questions or comments, please let me know. If you have any topics you'd like to see covered, please let me know as well. Thank you for watching.